So supposing that Auburn wins 75% of their games, what is the probability that Auburn will go 10-3 this year? All right, we can't solve this problem yet, but we're going to get there. So I want you to keep this in the back of your mind. Before we get there, let's think about it. What is the if the probability that Auburn wins is 75%, what is the probability that Auburn loses? Just hold on to all this information. We'll come back to this problem as we go. So before we can get to this problem, there's a couple things we need to talk about. So we'll call this example. The first thing we need to talk about is permutations. Permutations versus these things called combinations. You can write this down. Permutations before combinations. Permutations versus combinations. For permutations, order matters. For combinations, order doesn't matter. All right. Suppose that you are, I don't know. Suppose you're at home on a Saturday and you've got some time. Okay. And you've got you want to watch some Marvel movies. Okay. So y'all give me 4 Marvel movies. All right, so we got Civil War, we've got Endgame, we've got Black Panther. Give me one more. I think Spider-Man is just gonna be easier to do. I just don't know how to spell Shang-Chi. All right. So let's say these are the 4 Marvel movies that you have, okay? You got Civil War. Are y'all just laughing? Y'all writing stuff down? You got Civil War, Endgame, Black Panther, and Spider-Man. But let's say you only have time to watch 2 movies. You only have time to watch, well, actually, let's say you have time to watch 3 of these 4 movies. Okay. So let's think about what you could do. Basically, you could watch Civil War first, then you could watch Endgame, and then you could watch Black Panther. Or you could watch Civil War, and then Black Panther, and then Endgame. Yes, we are really making this list. Or you could watch Civil War, then Endgame, then you could watch Spider-Man, which I'm actually going to rewrite these real quick. It's going to be easier if I do it this way. No, you don't have to start all over again. I'm just doing it for me. So Civil War, I said Civil War, Endgame, Black Panther. Then I said Civil War, Black Panther, Endgame. And then I said Civil War, Endgame, then Spider-Man. Then I could do Civil War, then Spider-Man, then Endgame. Or I could do, let's see. I could do Civil War. I think that's all the ones that start with Civil War, I think. All right. Or I could do Endgame, then Black Panther, then Spider-Man. Or I could do Endgame, then Spider-Man, then Black Panther. Or I could do Endgame first, then Civil War, then Black Panther. Or I could do Endgame, then Black Panther, then Civil War. Or I could do Endgame. Oh, there are 24 of them, guys. Don't worry. We got plenty of time. All right. Or I could do, we're going to do them all. So I could do Endgame, then I could do, let's see, what are we missing here? Spider-Man, then Civil War. Or I could do Endgame, then Civil War, then Spider-Man. Is that all of those? Yeah, I think so. I think we're missing a C. Yeah. So Yes, you're right. No, CSB. Okay. And then we can start with Black Panther first. So let's see. Black Panther, then Spider-Man, then Civil War. Black Panther, then Civil War, then Spider-Man. We could do Black Panther, then Endgame, then Civil War. We could do Black Panther, then Civil War, then Endgame. We could do Black Panther, then Endgame, then Spider-Man. We could do Black Panther, then Spider-Man, then Endgame. I think that's it for the Black Panthers. And then for Spider-Man first, you could do Spider-Man, Black Panther, Endgame, Spider-Man, Endgame, Black Panther. We could do Spider-Man, Civil War, then Endgame. Then we could do Spider-Man, Endgame, then Civil War. Then I could do Spider-Man, Civil War, and Black Panther. Spider-Man, Black Panther, and Civil War. And I think that's it. That's 24. Connor, you got to learn how to be patient. Just wait. Just wait. It will be apparent eventually. All right, note. How many of these are there? There are 24, right? In other words, here's what we've got. We've got 4 options, and we're picking 3 of those options. So here's what you want to write. We're going to do 4P2. P stands for permutations because order in this case matters, right? The order in which we picked them does matter. So if I wanted to figure out what 4 permutation of 3 is, basically what this is going to be 4 times 3 times 2. Why? Because we start with 4 choices, then we have 3 choices after we pick that first one, then 2 choices after that. And the answer is 24. We did all of them. Everybody following me so far? Do y'all see how the 2 are related? So assuming that I had 5 movies instead, if I threw in there Shang-Chi or whatever, and I wanted to pick 3, what would that be? 5, then 4, then 3. Does that make sense? Okay, which this in this case would be 60 choices, which we're not doing that. It's easier than writing all this out. Wouldn't you agree? Now, combinations are different. Combinations say, I don't care about the order they're in. What does that mean? If you don't care about the order, that means this piece is the same as this one. Does that make sense? So the order doesn't matter, which would also be the same as this one, which would also be the same as this one, which would also be the same as this one, which would also be the same as ECB. Where's ECB? Right there. This one, which would also be, I think that's all. Yes. Yeah. Y'all, so these 6 would actually be the same thing. Then let's find the rest of them. So CS would be the same as CSE, would be the same as ESC is ECS, would be the same as SCE and SEC. Then let's do another set. We got EBS would be the same as ESB, would be as SBE as SEB, would be the same as these 2 right here. And then the last would be BCS and CBS and all that junk right here. So this one would be the same as this, be the same as this, same as this, same as this, and same as this. Actually, let me pick a different color here. Everybody see what I'm saying here? So if order doesn't matter, there really are only in total 4 choices. So once again, this is 4, choose 3 now. So once again, if order does not matter, then there's a significantly less choices. Now, we have learned from lesson 3 how to calculate this, correct? In lesson 3, we said 4 choose 3 was 4 factorial over 3 factorial times 1 factorial. Right? Y'all remember that from lesson 3 for those of you who did lesson 3. So this right here will be 4 times 3 times 2 times 1 over 3 times 2 times 1 times 1. This is from lesson 3 on combinations. 3 times 2 times 1 cancels with these. You have 4 over 1, so that's equal to 4. And we can see that the combinations are just 4 of them. Everybody following me so far? So check this out, guys. Check this out. Basically, what combinations are is we get rid of all the duplicates. Does that make sense? Permutations are always going to be more, pretty much always going to be more than combinations, because permutations care about the order, combinations don't. So we get rid of the duplicates. Does that kind of make sense? Okay. Keep that in the back of your mind as we go into the next situation. So we'll do example 2. So example 2, suppose there are 3 males in the class and 2 females in the class. What is the probability that if a random student was chosen to the board, what's the probability that student would be male? 3 out of 5. Real simple, right? What would the probability be that that student would be female? 2 out of 5. Everybody following me so far? All right, what's the probability that I pick a male and then pick another male? Yeah, they sit back down, yes. So it'd be 3 out of 5 for the first one, and the next one? 3 out of 5. And if you multiply those together, well, 9 out of 25, because you're multiplying straight across. That's not 6 out of 10. It's 9 out of 25. All right. What's the probability that I pick a male and then I pick a female? 6 out of 25. What's the probability that I pick 2 females? Yeah, it would be 4 out of 25. And what's the probability that I pick a female first and then a male? It'd be 6 out of 25 too. Because basically, if you think about it, picking a male person and then picking a female is the same as picking a female and then picking a male. Would I be correct in that? So here's my question. Shh. Listen up. If I pick 2 students, what's the probability that one is male? Not exactly. What are the 2 scenarios when one of the students is male? There are 2 scenarios. One is this one right here. The other one's this one right here. So in other words, the probability that one is male is the probability that I picked a female first and then a male, plus the probability that I picked a male and then a female. And that would be what? Six out of 25 plus 6 out of 25 would be? Plus this time. So we're adding the 2 probabilities. So probability that one of the students is male would be 12 out of 25. Everybody got that? Y'all got that down? All right. Does everybody understand this piece? Okay. I sure hope so, because I'm about to make it more complicated. All right. Check this out. What is the probability? Same situation. Well, what is the probability instead of picking 2 students? Let's say I pick 3. What's the probability that I pick a male, then a male, then a female? So it'll be 3/5 times 3/5 times 2/5. Everybody got that? 3 times 3 times 2 would be 18. And 5 times 5 times 5 is 125. All right, what's the probability that I pick a female first and then a male and then a male? Yeah, it would be the same thing. Why? Yeah, well, yeah, the position is just different. What about the probability that I pick a male first and then a female and then a male? Same thing. Are these the only ways I could pick 2 males? Yes. Right. These are the only ways I could pick 2 males. So let's think about it real quick. What is the probability that I pick 2 males out of 3 students? In other words, if I pick 2 males and there were 3 students picked, what's the probability that I'll pick 2 males? Well, these are the only 3 possibilities for picking 2 males, correct? So what did we do the last time? We did what? We did what with the probabilities? Add them together. So shouldn't we do that here? So 18 plus 18 is 36, plus 18 is 54, I think. So 54 out of 125. Now there's another way to do this, and that's using this formula. So the probability, okay, that you get X successes, you're gonna write this down, you're gonna need this formula, is equal to the combination of N choose X times P to the X times 1 minus P to the N minus X. Just write down the formula for now. Just write down the formula for now. I will explain it. I promise. Represents the total trials. I want to find the probability that I pick 2 males out of 3 students. So how many trials would there be total? In other words, how many students are being picked? 3. So N would be equal to 3. What is the probability that I pick a male? No, the probability that I pick a male. 3 out of 5, right? We've done this, right? But what is P equal to? How many successes do I want? How many times do I want to pick a male? I want to pick a male twice. Everybody follow me so far? So the total number of trials, N is 3. The probability that I pick a male is 2. And then, not P is equal to 5. I want X is equal to 5. X is equal to 2, rather. Y'all follow me so far? So now we're going to plug it into our formula. So the probability that you pick 2 males out of 3 students is going to be the combination of 3 choose 2. I'm just filling in the blanks. 3 choose 2 of P, which is the probability that I get a probability of my success, 3/5 to the 2 times 1 minus P would be what in this case? In other words, if I pick a female, we found that was what? What's 1 minus 3/5? God, come on now. If you pick two males, right, then the other person picked would be a what? Right. And what's the probability you pick a female? It's 2 out of 5. Oh, we do. I have to teach y'all how to add fractions. I mean that's not good. 2 out of 5. 2 out of 5. 2 out of 5. So these are the successes. These are the failures, if you would, basically. 2 to 1. That'd be n minus 2. N minus x. N minus x would be 3 minus 2 is 1. All right, so then we walk through it. The combination 3 of 2, that'd be 3 factorial over 2 factorial times 1 factorial, which if we use Desmos, which comes in handy here. If we use Desmos, we can actually, it's got a thing that we can use here. So we've got 3 factorial, so 3 factorial, or, as some people like to say, 3. Yeah, no one said that. It's lame, but still. All right. And so, and then times 3 over 5 squared. So we'll do that. Yeah. And then times 2 over 5. So 0.432 is our answer. Now check this out. Remember, we actually already did this problem. It was up here. Right? So let's see if we got the same thing. 54 over 125. And would you look at that? We've got the same answer. Does that make sense? So this formula is a way of doing it without actually writing all this junk out. We're not. We haven't got to that yet. No. All right. Let's go back. Let's go back to our very first question. The question was Auburn's winning percentage was 75%. What's the probability that they go 10-3? So the probability they go 10-3, write this out. This is the last thing we're doing. We're done. They play 13 games and we want them to win 10 of them, right? And then times the probability that they win was 75%, right? 0.75. We already did that. Times the probability that they lost was 0.25. Now, we want them to win 10 times, so you raise this to the 10th. And if they win 10 times, that means they would lose 3 times, so to the third. Then we're going to take all this information and plug it into Desmos. You see how quickly we can do this? It's actually not that bad. Then we do 13 factorial, and you got 10 factorial over 3 factorial to, thank you, 0.75 to the 10th and 0.25 to the third. And the answer is 25%. Mr. Brooks, why would we have to do that if we already know what percent? Yeah, that's the answer.